Today's notes are on section 3.1, exponential functions. So an exponential function is defined in the form f of x equals b to the x, or we just replace that f of x with y equals b to the x. This is important. B is a positive constant other than 1. So b is greater than 0. That means that the constant is positive, and b is not equal to 1. And our x can be any real number. So the first thing that I'd like you to do is I'd like you to determine if the following are exponential functions. So remember, you are looking for the form the function equals b to the x, where b is a positive constant other than 1. So pause the video now and check. So f of x equals x squared is not an exponential function. We've already covered these. This is a quadratic function, right? And our issue is that our variable is in our base, not in our exponent. G of x is an exponential function. It looks a little strange, but we remember that pi is about 3.14, right? So that means our base is positive and greater than and not equal to 1. For h of x, it is not an exponential function because here our b is equal to 1. Our base of the exponential expression is 1. It was not allowed to be 1. Similarly, for our next function, our b was negative 1. That's not positive, so that's not going to be an exponential function. And for our last one, our problem is that the variable is in both the base and in the exponent. And our definition says that it needs to be a positive constant. Okay, so x is not a constant, it's a variable, so that's not going to be an exponential function. So our next activity is to graph f of x equals 2 to the x. So we are going to start with just a table. And now this is our basic exponential function when we have a base raised to an exponent. So this is a new parent function for us, one that we want to become familiar with. So anytime you have a basic exponential function where your base is positive and not equal to 1 and your variable is x, you can start creating the parent function by just using -2, -1, 0, 1, and 2 for our x values. And so next, all I want you to do is evaluate this. So think 2 to the -2. If you can do that in your head, you're writing it right away. I can see, for those that need a couple more steps, that this is 1 over 2 squared, which is 1/4. Similarly, 2 to the -1 is 1 over 2 to the first, which is 1/2. Next, 2 to the 0. Anything to the 0 power is equal to 1. In our next ones, 2 to the first is equal to 2. 2 to the second is equal to 4. So now we just want to graph this. So I can see my numbers. I have -2, -1, -2. I have 1 and 2. Here I can see that I need to get up to 4. So 1, 2, 3, 4. I'll go a little farther. 5, 6. And down here I'll go -1, -2. So this was 6. Okay, and now pause the video and just graph those points. So here I can see that I kind of have this curve shape. So I want to see what happens when x goes to -infinity. So let's just plug it in. Then we would have our y equals 2 to the negative infinity, which is equal to 1 over 2 to the infinity, which is 1 over infinity. So 1 over infinity, what did that go to in our polynomial functions? That approaches 0. So as we get way down to negative infinity, our graph is going to get closer and closer to 0. Hopefully you remember closer and closer to 0 or closer and closer to a number indicates a horizontal asymptote. So here we actually have a horizontal asymptote at y equals 0. So I'm going to draw that asymptote in. And then as x approaches infinity, I have y equals 2 to the infinity, which hopefully you recognize that goes to infinity. So that means as I go right on my graph is going to shoot way up to infinity. I'm also just going to think if I had 3, 2 to the third would be 8. So I'm actually growing really fast here. And I just draw it in the graph with a smooth curve. And I put an arrow at both ends to show that it keeps going on forever. So important, this is called an exponential curve. Okay, when we had degree 1, we had linear functions or lines. When we had degree 2, we had quadratic functions, and we also called their special name was parabola. Whenever we're describing a graph, we want to call it an exponential curve. Okay, so pause the video now and see if you can determine the domain, the range, and whether this graph is increasing or decreasing for all values of x. So pause the video now. So here, this was a clue. Up in my definition, x is any real number. And also looking from my graph, I can plug in any value between negative infinity and infinity. So my domain is from negative infinity to infinity, all real numbers. For my range, my graph is going to get closer and closer to y equals 0, but always be positive. So my range is the positive numbers from 0 to infinity, not including 0. As far as increasing or decreasing, I always think of increasing. If I walked along this graph, if I'm going up the whole time, then I'm increasing. Each consecutive y value from left to right is higher. Okay, it's increasing. So this graph is increasing for all x. And we already went over that we have a horizontal asymptote at y equals 0. So let's try our next example. So I have x and I have y. I'm going to start for exponential functions with those same x values, -2, -1, 0, 1, and 2. So this time I have 1/2 to the -2. I recognize that is the reciprocal to a positive, 2 squared, so this becomes 4. 1/2 to the -1 is 2. 1/2 to the 0 power is 1. 1/2 to the first is 1/2. And 1/2 to the second is 1/4. So pause the video graph this function and see if you can fill out the domain range, whether it's increasing or decreasing for all x, and the horizontal asymptote. So here I have my graph. I have -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. I can see that as x goes to negative infinity, it's really going to go to 2 to the infinity, which is going to infinity, so it's growing really sharply. When x goes to infinity, this goes to 1 over 2 to the infinity, which we said went to 0. So I have that same domain, negative infinity to infinity, because I can plug in any value for x. My range is, I'm still dealing with all positive numbers. This time I'm decreasing for all of my x. Okay, if I was to walk this, I would be going downhill the entire time. And I have a horizontal asymptote at y equals 0. Okay, because my y is approaching 0, but 1 over 2 to the infinity will never equal 0. So a couple things here. Please make sure you're using a pretty even scale. Okay, you don't necessarily have to take out a ruler, but they should be pretty even, right? As close as you can get them. That comes with practice. Also, please make sure for these graphs that you put in any asymptotes that you have. Okay, I will give you a hint in exponential functions, we're only dealing with horizontal asymptotes. Okay, please make sure you watch part 2 of the video.